All right, guys, these are the notes for simple probability. So, what is probability? Probability is the chance that some event will occur. It is written as a ratio or a fraction in simplest form. How do I write the probability of an event? So, we always write P equals, and it's a long fraction only because we're going to write words here, but the fraction itself is actually really small. So, for here, we're going to write on the top, it's always the number of outcomes for a given situation. Squeeze it in there. That's what number always goes on the top. And on the bottom is always the total number of outcomes. Okay. So then we have something called a probability scale. And the probability scale shows the likelihood an event will occur. The closer the probability is to 1, the more likely an event will occur. The closer the probability is to 0, the less likely it will occur. An event that has a probability of 1/2, we say, is equally likely. So here's my probability scale. So I've already labeled anything from here to here we call unlikely. And anything from here to here we would call likely. The only thing that's equally likely is if it's a 50%. And then we have two words that are left off, so we're going to add them. If something for sure will happen, like if I flip a coin, I'm for sure going to land on heads or tails. We call that certain. It will certainly happen. And then on the other side, if it has a probability of 0, for instance, if I roll a dice, what's the probability I'm going to land on a 10? Well, there's no 10 on a die, so I would say this is impossible. Now, we're going to practice writing different probabilities as a fraction, decimal, and percent, and we're also going to state the likelihood using one of these 5 words of them occurring. There's something else I want you to be aware of. There's something called a complementary event. So, 2 events in which one or the other must happen, but they cannot happen at the same time. For example, using the letters MATH for math, there is a 1 in 4 chance I pick a vowel. Its complement then is there's a 3 in 4 chance that I pick a consonant. So a complementary event is always labeled like this. You know how normally we have P and then in parentheses it says something? Well, this is called P prime. And it looks like an apostrophe, but in math language we call it prime. And that means you're finding the complementary event. It's like thinking of the word not when you read it. So when you're trying to find the complement of something, you're saying, like here, what is the complement of picking a vowel? Then what is the probability of not picking a vowel? That would be a consonant. So let's do some practice on the back. As a coin is tossed, what is the probability it will land on heads? So there's 2 sides of a coin, and only one of them have a head. So I know my probability is 1/2. We're going to do a little bit of practice of fractions to decimals to percents today. So make sure you have your calculator out. So remember, to make a fraction into a decimal, I do 1 divided by 2, which you should know is 0.5. And then as a percent, remember, we move the decimal point 2 places to the right, so that's 50%. And then we're going to use one of the words from the front to describe the probability. So 50%, that's the one that we call equally likely. Looking at the spinner to the left, find the probability of each event occurring. So here we go. Here's my spinner. What's the probability I'm going to spin a bee? Well, there's only one bee, and I'm going to count the spaces 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible spaces. So I would say 1 out of 8. We're going to use our calculator. 1 divided by 8 should give you 0.125. Move the decimal point 2 places to the right. That would give me 12.5%. And if I had to pick a word from the probability scale, I would say that it is unlikely that I will spin an letter B. It's less than 50%, but it's not impossible. Right? The probability I will pick a C or a D. So again, we know there's 8 spaces. Now we have to see how many of them have a C or a D. So there's 1, 2, 3. So we're going to say 3 out of 8. Let's convert that into a decimal. So 3 divided by 8 is going to give you 0.375. As a percent, that's 37.5%. And again, it's less than 50%, so we're going to call it unlikely. What's the probability that I'm going to pick a vowel? So remember, you need to know your vowels. They're A, E, I, O, U. So I, again, know there's 8 spots. Let's count how many are in A, E, I, O, or U. So 1, 2, 3, 4. So I would say 4 out of 8, but of course we simplify our fraction, so 1/2. I already know from above that 0.5, which is 50%, which is equally likely. So if you're trying this from home, I would really like you to try these ones on your own and see if you can figure them out. Stop when you get here. So I want you to try these using the dice and this using the spinner. So put me on pause, try them, and then see if you were right. So pause me now. All right, let's see how you did. So my answers for these ones should look like, I'm just going to put up the answer key. So the answers like for this one should look like this. Here I have 1/2, equally likely, 1/3, unlikely, probability of a 9, can't roll that, so it's impossible. Here, the probability of spinning a 7 is 1 out of the 10 spots have a 7, so unlikely. A number greater than 0, all of them are greater than 0, so that's 10 out of 10 or 1, which is certain. And a number between 3 and 9, and this is where you got to be careful. Between 3 and 9 means do not include 3 and 9. So 4, 5, 6, 7, and 8. That would be 1/2 or equally likely. Now for the other ones, it says find the probability of the complement of each event. So I should have put in the prime symbol. So in your head, you think of the word not. So don't find the probability of 1 or 10. Find the probability of not being 1 or 10. So there's 10 spots. And what's the probability of it not being 1 or 10? That's 1, 2, 3, 4, 5, 6, 7, 8 spots on there are not a 1 or a 10. Or 4/5. I know that's 0.8 as a decimal. I know that's 80%. And if it's 80%, that's higher than 50, but not 100. So we would say it's a likely event. And then we have P prime. So the probability of not spinning an even. An awful lot of these ones. I'm going to have to change this for next year. So you should have 5 out of 10, which is 1/2, which is 5/10, which is 50%, which is I almost messed up, equally likely. So all of these probabilities that we've talked about today are the same type of probability. It's called theoretical probability. And theoretical probability is what should, underline should, happen given the facts. Okay. I know I should flip heads half the time and tails half the time. I should roll a 1 on a die 1/6 of the time. I should, on this one, spin a 8 1/10 of the time. That's what should happen. But a lot of times, what should happen doesn't match what does happen. And that's experimental probability. So, experimental probability is what actually happens during the trial. And the trial is just a fancy word for experiment, but they'll call them trials. So, in class, I had the students do this, and you can try it. I had them figure out the theoretical probabilities for each of these happening on a die. And then they conducted their own experiment and figured out how many times they rolled each number, and they rolled the die 30 times. So if you have a die at home, you can do this. You can conduct your experiment. And then I'll show you what one would look like. Let's say I rolled the number 4 8 times. Okay, so the probability of 4, I would see that I rolled it 8 times. And then the bottom number is always how many times you roll the die. In this case, I rolled the die 30 times. So I would say 8 over 30. Or in simplest form, let's see, what would that be? 4/15. So when you do an experiment, the bottom number isn't any longer going to be how many sides there are in a die. It's going to be how many times you rolled it. So I rolled it 30 times. That's my denominator. That's all my possibilities. And then 8, that's the number of times it occurred. And then what you can do is you can compare your data. Okay, what should happen to what actually did happen. Now in class, we're going to kind of skip this part for you guys, but in class we combined all our data together and then did the same probability questions for a third time. And what we saw is when we just did the data by ourselves, a lot of times our percents were way far off from what they should be. But when we collected our data all together as a class, because we had more and more trials, it got closer to what it should be. So what do you notice when you compare the experimental probability with the theoretical probability? You should notice the more trials you have, the closer the experimental will get to the theoretical probability. So the more trials you have, the more and more and more we do it, the closer and closer and closer and closer our experimental probability will come to our theoretical probability. And that's where we stop today. If you have any questions, please feel free to email me.